One of the main challenges that we're working on here at MIT at our new Internet Policy Research Initiative, which we really consider to be part of the web science effort, is trying to help understand public policy issues raised by the web, and in particular to help provide policymakers around the world guidance about how to help the web grow, how to help realize values that we all have, including access, freedom of expression, privacy, security, and promoting democracy. So I think that we see the web technology continuing to develop in extraordinary ways. One of the main challenges that we see is we want to help the public policy community and government officials all around the world understand how to support the development of the web and how to help align the web with some of our basic values.
Three big things I think we should worry about. The first is the have-nots. I don't think this is just going to get sorted out because everyone's going to be online. I think that has been what people have been saying for the last 10 years while I've been working in the skills area. I think we have to make a really concerted effort to make sure people are not left behind, whether it's through price, through skills, through location, whatever it might be. And then the second thing I'd say is the inbuilt biases that might happen in some of these systems when more and more complexity is introduced to the system is very, very important, whether it's bias towards particular racial tension issues, whether it's biases towards gender. And something that I'm very interested in at the minute is, with the advance of AI and the huge shifts in machine learning, it's going to be very, very clear that you're building systems that are going to be additive to all of us as human beings and are not going to replicate some of the mistakes that we've made over the course of our short history.
The challenge is to be able to extract from the R&D science development the right components and to show to the industry that there is a lot of value around this. So we must be sure that part of several research you could have in one university is not specifically for Southampton, it's at the global level, but there is a very strong core development already there that we need to extract the concept, the idea, to be able to provide this to a global basis for the web. So I think the challenge is to be able to find the right subject and to extract it when it's ready to go to upper level.
As human beings become more and more dependent on the devices in their pockets and the devices in their homes that generate these huge quantities of data, it's going to become ever more critical to understand their behaviours and the data that's being generated in order for it to be properly used for the benefit of mankind and for commercial exploitation.
Continuing to develop web science as a rigorous discipline alongside big data, AIs, the Internet of Things, social media, the cloud, and so on. Next, getting a much better handle on security and privacy, cybercrime and cyber warfare. And then improving global regulation and the legal frameworks needed for public trust and acceptance, while continuing to fight the battle for a healthy balance between giant global corporations and public society, governments, academics and individuals. But the biggest challenge of all will be just keeping up with the frantic pace of innovation and the hugely expanding scale of the global web. We ain't seen nothing yet.
I'm shocked that people don't know the difference between the World Wide Web and the Internet, because I compare it to the ocean and the boats. The Internet is an ocean of protocols and messages going back and forth amongst millions and billions of points, and the World Wide Web is the little floating windows that we see, which only use some of the protocols of the Internet. And not understanding that, it puzzles me how these young people think they're in the swim when they're using Facebook or all these capture services. All these monopolies are capturing the kids, and they think they're pioneering. This is very troubling to me. That there's no sense of what goes on underneath. There's no sense that people think that computers have some nature. I mean, computer is the myth of technology. What most people call technology is about constructs and packaging. What is the iPhone? It's constructs and packaging. What is a computer but constructs and packaging? What is the World Wide Web? Constructs and packaging. And then people take this these phony objects floating past them as reality, and accept the monopolies that have been built on them suddenly in the last decade or so in ways we did not expect.
When I now visit a web page, I'm no longer anonymous. I may be logged into a Google account. I may be tracked by a Facebook like button. Maybe I use my smartphone to enter somewhere and I'm tracked where I'm going. So rather than that the web is something that's just there and waiting for me to pass by, the web is offering me a very personalized view based on who I am, where I am, what I'm doing, and gives me also very clever recommendations of what product I might want to buy. The disadvantage, of course, is that I'm also observed a lot of the time, and the question is, to which extent is this always legal? To which extent is it ethical? And to which extent do I really want this as a customer?
It's even more important that web science exists today than it did 10 years ago. We're at quite an important tipping point with the web and the internet on which it sits, in that the pressures on the internet have never been so great. There's so much about market forces, the big companies whose very existence depends on this system, but it's a system they want to control for their own ends. 10 years ago, they weren't such big or so powerful. And of course, we need them to exist. But it's all about how do we keep the balance between the open and free internet and the market forces from the commercial world. And then you've got the geopolitical forces. You know, countries want control over the internet. They're talking about creating their own internets, and I've heard the term splinternet. And, you know, we have to think about what that would mean. And you can't just think about that from a technical perspective. You have to think about it from a point of view, what are people going to do? So it makes the role of the web scientist, the people who can look at this from a perspective other than just the technological perspective, so important, because we need to help governments with their policy making. We need to help businesses make intelligent decisions about what they need to do to keep their business going, but make sure they don't kill the goose that laid the golden egg as they build their business.
There are very many challenges. Let me take one that's very clear as Internet of Things is upon us and the data supply is enormous. Are we ready for that? I think in many ways what we've been doing in web science, the methods we've been establishing are a rehearsal for Internet of Things. But Internet of Things is machine to machine. It shows far more automation in what's going on. And automation is something we should really think about. A good example of that also is what's going on with the platform providers and the use of algorithms, the sort of echo chamber effects. And I think this needs inspection and reflection and ethical attention. I think also that the community has a role in reaching out with sort of web science thinking more broadly, and it's in a great position to do that because it is such a diverse community. But we really need web science thinking to be occurring across very many communities, including ourselves, the process of scholarship itself.
I think the challenges facing web science are the fact that other disciplines would think that they are either more important or different from web science. Web science, as a number of people have said, is a boundary object. So really, I think that's the beauty of web science, is that you can look at web science and you can find what you want in it, because it's around this notion, and I know some people disagree with it, but I really like the notion of the social machine, because if I go out to groups in government or business or community groups and I talk about the social machine, people get it. They get it and they understand the importance. The second thing I think that's a challenge for web science is to actually articulate what it does specifically within the academic realm but beyond. I think the opportunity and the necessity of web science is in getting people to ask the fundamental questions about what it is to be human, about what the values are, about the ethical and moral framework within which the social interaction of humans and technology is taking place. And those questions are crucial because change is happening so rapidly that people are not taking time. They don't actually have time to step back. a conversation I was having with a girl a minute ago. She was asking that very question, and I said, it's all about starting to be proactive rather than being reactive, and I think this is actually what web science needs to do.
We thought 10 years ago that we were starting to live in the future because we were seeing cyberspace come into reality, and we were seeing URLs on the sides of buses and all sorts of our lives starting to be lived online. Now we're living in a new kind of science fiction future in which our fridges and toasters are starting to attack our online lives. So just a week ago, we had a very high-profile cyber attack which was caused by botnets made of things in the Internet of Things, which were unsecured, and domestic appliances being used to attack major American companies' websites. That is just insane and crazy. And so what web science has to do is to help us negotiate and navigate and understand the tremendous opportunities and also the tremendous risks, and try to come forward with some way through those. That's the big challenge, I think, in the next 10 years.
One of the reasons I think web science was the right thing to do is that you can't pick up a paper on any average day without seeing a web science question in there somewhere. They may not call it web science, but literally in the news at the moment was the issues around cyber security. How safe is our information fabric, both the web and the more general internet? Questions around how the web is used democratically. How is information passed around and through the web? Do we need to worry about the truth or falsity of facts? How do rumors spread? How do we understand how the web is used in the political process? And then simply in areas where it's amplifying our ability to do things. We see examples of the web used in humanitarian crises, in helping make scientific discoveries by pulling researchers together. And there are challenges around who owns the web, or where all that data that we generate and contribute to the web actually ends up. The question there is, what about the great internet platforms, and how, as researchers, can we get access to that data in just the way those companies can, to understand the science of the web? Looking to the future, certainly these problems will persist. There's no doubt that we'll worry extensively around security of the web. We will have challenges around ensuring that it is fair and equitably distributed. We'll have challenges around the notion of artificial intelligence in the web, just how much decision making is being taken algorithmically by machines and how much by people. And we'll want accountability of both those processes and also the data on the web. And I think we're going to see a huge explosion in the Internet of Things of new devices connecting to the web, many of which will be machine devices, making decisions, recording information. And so the whole systems biology of the web, so to say, the whole systems level approach is going to have more components, not less. Very shortly, we'll have more than 50% of the planet accessing the web. And there's more to go, of course, and that all adds even more urgency into the question of understanding the web's properties.
The challenges facing web science over the next 10 years, I'd really like to see it focusing more on how the web integrates with daily life and, if you like, global happenings. So, you know, an example of this is the kind of automated production and propagation of content, information and misinformation recently around the US election, for example. It is often a distinction between what happens online and offline, and we know to some degree this is the case, but there's also, you know, a definite impact when real-world events are shaped by online occurrences, and web science gives us, you know, strong opportunity to look at that, and that's going to be a big challenge going forward. Also, the global politics of the web in terms of ownership and the evolution of the web over the next 10 years. For example, smartphone apps are now pervasive, and social media companies have embraced this. So, for example, Facebook's got billions of users globally, and a lot of web content is actually consumed now through things like the Facebook app. which is fine. Essentially renders it as a web browser would, but the issue there is that Facebook, of course, curate this content and promote content, and other content can be hidden. Not necessarily saying that anything is deliberately promoted or hidden, but because of algorithmic bias, we are inevitably going to see some stuff promoted higher than others, and web science has a really interesting challenge in studying how that happens, and I guess kind of intervening and, to some degree trying to make this open and up for debate in terms of ownership and the politics of the web.
We've been using the World Wide Web as a way of sharing information for quite some time. It's become more and more elaborate as time has gone on. The websites now contain software which we download and interpret in our browsers. This is a far cry from the early days of HTML, when all we had was formatted text and a certain amount of imagery and eventually video and audio. But today we have a very, very rich computational environment in which the World Wide Web is embedded. On top of that, we have increasing amounts of data that's stored away in forms that are not easily indexed by our conventional indexing search tools, like those that are executed by Google, by Microsoft, and others. And so part of the challenge of web science is to find ways of making that content not only more visible, so it's discoverable, but also more useful because it has information associated with, or metadata associated with, the content. Finding standardized formats and ways in which to expose that information and to make it more useful is part of the challenge of web science. And as we enter into this age of increased artificial intelligence, where we're starting to use deep neural networks and other kinds of methods, including Bayesian mathematics, to find information and make it more useful, we have an opportunity to expand our scope in the world of web science.
We are living through challenging times, and if we have learned one thing looking back at 2016, it's how important it is that people engage with technology, engage with digital channels. And there's been a lot of discussion already about the role of the web technology, social media platforms, algorithms that empower all the platforms we are using in our daily lives. The role of all these artifacts on what is going on in the real world, how decisions are taken, how elections are decided. And I think the outcomes have shown that we need more than ever to think about how to make technologies and digital means more engaging and more relevant for every individual, not just for specific communities or groups of people.
I guess one of the challenges we have to think about in the years to come is to include modern methods of machine learning and artificial intelligence into our web science endeavors, because what we need right now are methods, computer algorithms that will assist us in understanding how people use the web. For instance, algorithms that would help us to understand the content of tweets people tweet on Twitter, or understand the content or the sentiment expressed in Facebook posts and the like.
The web generates a great deal of data, and that's great for understanding how people behave, both individually and collectively. And that's really kind of transforming many areas of research. But although we think of ourselves these days in a sort of deluge of data generated by the web, actually, increasingly, the web has become more fragmented, more kind of locked into proprietary platforms. And it means a lot of the data that we sort of think we have, we actually don't have, like Facebook data or Uber data or data from Fitbits and any other area of the so-called Internet of Things. And I think that's going to be a challenge for web science going forward, that we think of ourselves having data about every aspect of human life, and that actually we haven't, and we're going to need to develop the kind of industry partnerships and relationships with internet corporations that's going to make that possible.
If these systems, these socio-technical systems, haven't actually been recognised yet as socio-technical systems, the challenge is to actually articulate them for what they are, rather than two isolated systems, which is a group of people operating within an organised structure and a group of computers operating within an organised structure. So I think the challenge is finding a way to articulate what those systems look like and how they operate and how they can be analysed or bettered or optimised in a way that is useful.
We have had a very good beginning, but there are lots of questions that we still haven't answered. Just look at the recent things that have happened with elections all over the planet.
The web has given us many blessings and has provided us with many opportunities. We are still at the early stages of discovering how best we can leverage the opportunities provided by the web and how that is fundamentally going to transform the ways in which we organize society. That remains the challenge for web science in the future. It is not just sufficient for web science to describe how things are today, or even to predict how things would be tomorrow. It is the responsibility of web science to help us not only predict or describe, but to prescribe and to understand normatively how we can shape the web for a better tomorrow, for a better society, for all of us, and for the next generation.
There are many challenges ahead, to mention just two. First, as the web impacts our lives in so many ways, it is not clear which are the boundaries of web science. Second, web science should strengthen even more its relation to other disciplines such as economy and mathematics.
One of the main important issues is we have more and more intelligent algorithms, we have more and more suggestions by what we build as computer scientists, and we have to make these suggestions and these recommendations and possibly also decisions in the futures made by algorithms more transparent and more fair. And we might actually see these decisions and suggestions on portals on the web where, for example, the algorithms behind make suggestions how to make financial decisions, how make suggestions how to take decisions in your daily life. And this is not just buying books, right? If suggestions and recommendations are made for which book to buy, this is a very harmless decision. If I make a wrong decision, I have a wrong book at home, which I don't really care about, which is not really bad. But if an algorithm makes deeper suggestion, for example, about medical treatments, about financial decisions, etc., it really has to explain, be able to explain how this decision is taken, so that you or we, as the ones who then act on this decision, actually can estimate or can appreciate the decision, or maybe also discard the decision because some factors or some aspects were not taken account of. So I think this is one of the most important aspects in future developments. We do not only have, or we should not only make algorithms smarter, we also have to make them more transparent, more fair, and more, let's call it, responsible.
The web isn't going to stay still, and even though we've made some remarkable steps forward in, as I say, bringing together people around the world and bringing together an understanding of the web that is technical and social and political and economic and cultural and all of those other things, the knowledge that we have now isn't going to be enough to help us to understand where the web's going in the future. It's really critical that we keep the faith, that we carry on doing web science the way that we've started doing it, and that we pull together really deep expertise. This interdisciplinarity has to be about respecting the deepest and the best expertise that we have, so that we can understand neural nets and network topology and social integration and criminal psychology and international privacy laws, and in particular how those kinds of things come together in ways that change what they are and change what we understand about them. So we really need to keep that going if web science is going to not only be really good at understanding the web, but also to have a hope of playing a part in shaping its future.